Well wishes to you all. In this video, we are going to learn about the Bohr's atomic model. What was the opinion of the Bohr regarding the atomic model? Dear students, you are well aware that different efforts were being made in order to have the atomic models, which kind of atom is looking for. And in this course of time, the name of Bohr was up to the mark because he was the scientist who thought that it is the angular momentum of electron which will decide about where the electron will be outside the nucleus. Then some postulates I am going to discuss about the Bohr's atomic model. The first one is, of course, the nucleus. Nucleus is a very tiny entity which is containing all the protons and all the neutrons. It is very small, very tiny and located at the center of that. Outside this, a lot of circular orbits are possible. As you are able to see, a lot of circular orbits are possible, but electrons are not going to rotate in all of these. Electrons are revolving around the nucleus only in the orbits which are having angular momentum. This is what we are calling angular momentum. The value of angular momentum is equals to n multiplied by h upon 2 pi. And the angular momentum, what I have told you already, that it is been represented by mvr. So electrons for which mvr, angular momentum, will be equals to n into h upon 2 pi, where n is a complete number integer, means its value may be 1, 2, 3, 4, 5, dot, infinite, but never a fraction and never zero. This what we call shell, and name the first cell as the K, second cell L, M, N, dot. So this was the first and I think so the most important postulate of Bohr's atomic model, that electrons are revolving outside the nucleus in a circular manner. A lot of circular orbits are possible around the nucleus, but electrons are not going to revolve in all of these. Electrons are revolving in only those orbits which are having angular momentum h upon 2 pi are a complete number integral of those one. So these what we call shell, also called as stationary orbits. These are also called as stationary orbits. Moreover, another postulate was very important there, and that is, if an electron is present in its orbit, it is neither going to lose its energy nor it is going to gain any kind of energy. Its energy remains constant in its orbit. However, when it is getting energy from elsewhere, suppose that sunlight is there on an electron revolving in its orbit, then it accepts a bit of photon and get excited into the higher energy level. So electron can move into the higher energy level by accepting a bit of energy, basically in the form of radiation as well you are doing. But here it is not very stable, and when it returns back, it evolves that equal value of the energy, that is delta is always equals to E2 minus E1. It means when electron is revolving in its orbit, its energy remains constant, and when it gets a little bit of energy from outside, it can be excited and moving into the higher energy level. But when it returns back in its original orbit, it releases the similar bit of energy back. It means energy of electron remain constant in its orbit. Finally, this was the basic proposal for the Bohr's atomic model, but this model is having various drawbacks, just like the first one is there. lot of circular orbits are possible around the nucleus, but students, you know very well that in 3D, circle is getting converted into sphere. It means this was a flat model. It was not talking anything about the 3D. Second, no inter-electronic repulsion is discussed. Dear students, Bohr have taken the example of the hydrogen atom, which is a monoelectronic system. Monoelectronic system is that one, either atom or ion, any species which is having one electron only, just like hydrogen, He plus or Li plus plus, which is having one electron only. So, no inter-electronic repulsion is being discussed in these one, while if it is carrying more than one electron, then definitely the repulsion forces should be there. But here the no repulsion forces are discussed so far. This model could not explain the star effect. What it is? Star effect means when electron is emitting energy, it is coming in form of radiation, and if you are having the spectrum, you can have the several lines in the spectrum. These several lines in the spectrum, when they are placed under the external electric field, they get splitted out, and this effect is called as star effect. This model was not able to explain anything about the star effect. Similarly, when the spectrum lines are placed in the external magnetic field, again it was not able to explain why the spectral lines get splitted. So, this model, Bohr's atomic model, was rather very good, but it was only for the monoelectronic system. It was not able to discuss the repulsive force operating between the different electrons. If more electrons are there, it was not able to tell anything about the splitting of the spectral lines in the external electric field or external magnetic field. So these are the drawbacks of the Bohr's atomic model. Thank you.